Yo Rana, and welcome to Stats Chapter 9 Invariant Population Means. In this question here, a group of college students reported their believed heights, and after that, the real actual heights are measured, and they want to see if there are some differences between the believed heights and the measured height. So in question A, they want us to find a 95% confidence interval for the mean difference. So if we click on the icon here, one column is measured and one column is believed. So if we want to calculate the confidence interval, we open the data in StatCrunch. And then since this study came from the same group of sample size of before and after, or the believed and the measured, so in this case we also need to use the paired t-test. And in sample 1 it's just man and var2, and then now we're not doing statistics, the t-statistics, but we're doing confidence interval. So we click confidence interval and we check that it is 95%, and then we press compute, and here is the upper bound and the lower bound of the confidence interval. So we round that to 3 decimal places as the question requires. Awesome. And then now we need to answer this, and it says that the interval, since it's from negative to positive, so the interval actually does capture 0, because in between the lower bound and the upper bound it captures 0. So it means that 0 is a possibility of the test, and the mean difference can be 0. So a hypothesis that the means are equal cannot be rejected. We cannot reject the probability that they can be the same. And in question B, perform a t-test to test the hypothesis that the means are not the same. So we need to find that they're not the same. Okay, so the null hypothesis should be they're the same, and the alternative should be that they're not the same. And to construct a t-test, we go back to StatCrunch, and go to stat, t-statistics, paired, man in the second column. So now we check this, we're doing not the same and the same. So here is your t-statistics, and we copy that, rounding to 2 decimal places, and the p-value is 0.455. So since the p-value is higher than the significance level 0.05, that's why we do not reject the null hypothesis, and the means of measured and believed heights are not significantly different. Click that, and thank you for watching.